we are going to see the solutions for linear non-homogeneous partial differential equation. Consider the general linear non-homogeneous PDE d minus m1 d dash minus c1 into d minus m2 d dash minus c2 into z equal to 0. Or sometimes in the right hand side they will give some function of x comma y. Okay. The solution for this non-homogeneous linear partial differential equation is z equal to complementary function plus particular integral. So for that we have to find complementary function first. So the complementary function for this type of non-homogeneous PDE is e power c1x f1 of y plus m1x plus e power c2x f2 of y plus m2x. This is the complementary function. Let us take it as case 1. Let us take case 2. Here the factors are not repeating. Two factors are different. Suppose the factors are same. Let us take d minus md dash minus c power 3 into z equal to f of x comma y. Here the factors are repeating thrice, 3 times. So complementary function is e power cx f of y plus mx plus x into e power cx f of y plus mx plus x square into e power cx f of y plus mx. Since the factor is repeating 3 times, we have to write 3 terms. If suppose the factor is for 4 times repeating, we have to write 4 terms. The next term will be plus x cube into e power cx into f of y plus mx. In this way we can find the complementary function, and particular integral can be found as usual we did in homogeneous partial differential equation. The same method can be followed. Let us see few problems. Solve d minus 4d dash minus 1 into d plus 5d dash plus 3 into z equal to 0. So before solving the problem we have to check whether the given PDE is homogeneous or non-homogeneous. Already I said the simple technique to find it. Just multiply this d into d square, it's a second order derivative. D into d dash, second order. D into 3, it's a first order. So the order of the derivative is not same in each term. It is a non-homogeneous type problem. Keep this in mind. We have to bring this form d minus m d dash minus c, so that we have to find the value of m and c to write the complementary function. Given d minus 4d dash minus 1 into d plus 5d dash plus 3 into z equal to 0. We have to bring this form. So rearranging this equation, d minus m d dash minus c into d minus plus 5 can be written as minus of minus 5 d dash minus of minus 3 into z equal to 0. Now we brought this given PDE in this term. Now what is m1? m1 equal to 4, c1 equal to 1, m2 equal to minus 5, c2 equal to minus 3. Now the complementary function is e power c1x f1 of y plus m1x plus e power c2x f2 of y plus m2x. Here the factor is not repeating. Two factors are different. So this is the complementary function. Cf equal to e power x f1 of y plus 4x plus e power minus 3x f2 of y minus 5x. Here the right hand side have no terms, so there will not be the particular integral. Only complementary function is the solution. Therefore the general solution is z equal to complementary function plus particular integral. So z equal to c of e power x f1 of y plus 4x plus e power minus 3x f2 of y minus 5x. Particular integral is 0, no need to write it. This is the general solution for the given non-homogeneous partial differential equation. Let's see the next problem. Solve d minus 2d dash plus 2 whole power 3 into z equal to 0. Here the factor is repeating 3 times. So solution, given d factor is repeating 3 times, it means we should write this as product of this term 3 times. Now m equal to 2, d minus, again you remember this, d minus md dash minus c. This is our formula. D minus md dash, m is 2, minus c, but here it is plus 2. We can write it as minus of minus 2. So c equal to minus 2. Now the complementary function for repeated factors, e power cx f of y plus 2x. Again you are writing the same factor, no need to write the indices f1, f2, plus x into e power minus 2x f of y plus 2x plus x square into e power minus 2x f of y plus 2x. And the general solution is z equal to complementary function plus particular integral. Here there is no term on the right hand side, so there will not be the particular integral. Now the solution is z equal to e power minus 2x f of y plus 2x plus x into e power minus 2x f of y plus 2x plus x square into e power minus 2x f of y plus 2x. This is the solution for the given partial differential equation. The 3. Solve d square minus 2d dash plus d dash square minus 3d plus 3d dash plus 2 into z equal to e power 2x minus y. So in the previous two problems, the left hand side is in the form, standard form itself, but here it is not in this form. Again you remember this, d minus md dash minus c, you have to bring this form. Solution, to find the complementary function, just take the left hand side of part only and write d square minus 2d d dash plus d dash square minus 3d plus 3d dash plus 2 into z equal to 0. Now this left hand side is not in this form, d minus md dash minus c. There is no specific method to simplify this partial differential equation in this form. But by trial and error method, we can simplify this homogeneous part. Look at this first 3 terms. You can write this part as d minus d dash into d minus d dash. D minus d dash into d minus d dash minus, this can be written as 2d minus d, 3d plus 2d dash plus d dash plus 2, everything into z equal to 0. Now d minus d dash into d minus d dash, just take minus 2 commonly, you will get a d plus, in these 3 terms we can take 2 commonly, 2 have taken, so d, here minus we have taken, so you will get minus d dash and minus 1. The remaining terms, what are the remaining terms? Minus d plus d dash, minus of d minus d dash, everything into z equal to 0. Now look at this first and third term, we have d minus d dash in common. So we can take d minus d dash, remaining another d minus d dash, minus 1 will be there, minus 2 into d minus d dash minus 1 into z equal to 0. Now we have 2 terms, in both the terms we have d minus d dash minus 1 is in common. Take it, d minus d dash minus 2 into z equal to 0. Now look at this, we have brought the form d minus md dash minus c, d minus md dash minus c. It is in that form. So for this problem, m1 equal to 1, c1 equal to 1, m2 equal to 1, c2 equal to 2. Complementary function e power c1x f1 of y plus x plus e power c2x f2 of y plus x. This is our complementary function. Now we have to find the particular integral. Since the right hand side have the function e power 2x minus y, you can find the particular integral too. Particular integral equal to 1 divided by the function of d and d dash, that is d square minus 2d d dash plus d dash square minus 3d plus 3d dash plus 2 into e power 2x minus 1. Here the coefficients of x and y, that is taken as a and b. The coefficient of x is 2, that is a equal to 2. Coefficient of y is b, that is minus 1. You have to replace d equal to a and d dash equal to b in this term. That is the procedure to find the particular integral. 1 by d square, that is 2 square, minus 2 into d dash plus d dash square, that is minus 1 square, minus 3 into 2 plus 3 into minus 1 plus 2 into e power 2x minus 1. Simplifying the denominator, 4 minus of minus plus 4 plus 1 minus 6 minus 3 plus 2 into e power 2x minus y. 4 plus 4 8 plus 1 9, 9 minus 9 0, you will get 2. 1 by 2 into e power 2x minus y. This is our particular integral for the given homogeneous problem. Now the general solution. Z equal to complementary function plus particular integral. That is Z equal to, already we found the complementary function e power x f1 of y plus x plus e power 2x f2 of y plus x and particular integral 1 by 2 e power 2x minus 1. This is the general solution. Let us see another problem. Solve 2d square minus d dash minus d dash square plus 6d plus 3d dash into z equal to x into e power y. This is also a non-homogeneous problem because the order, check the order, second order, second order, second order. This is the first order, first order. The order is not same in all the terms. So this is a non-homogeneous problem. So to find the complementary function, you just take the left hand side part only. 2d square minus d dash minus d dash square plus 6d plus 3d dash into z equal to 0. Compare this with the previous problem. Again, this is a homogeneous part and there is no constant part, so no need to worry about splitting of these two terms. Simplify this homogeneous part and try to find the factors. How to find the factors? Just product 2 into minus 1 minus 2 and sum is minus 1. You have to find two numbers such that the product is minus 2 and sum is minus 1. So you can write 1 into minus 2. Multiply it, 1 into minus 2 minus 2. 1 minus 2, that is minus 1. Sum is minus 1, product is minus 2. So this middle part is changed as 2d square plus dd dash minus 2dd dash. So this minus dd dash can be written as plus 1 minus 2. You will get minus 1 dd dash minus d dash square plus, here 3 is in common, we can take 3 outside, d 2d plus d dash into z equal to 0. Now take the common part in the first two terms, that is d, remaining 2d plus d dash. In this two terms, take the common part, minus d dash, get 2d plus d dash plus 3 into 2d plus d dash. Now look at this, in all the three terms 2d plus d dash is common, 2d plus d dash. Write the remaining terms, d minus d dash plus 3 into z equal to 0. Now we have to remember that once again, we have to bring this form d minus md dash minus c. This is our form. Here 2d is there, but in our form we have the coefficient is 1. Here the coefficient is 2. We have to make it as 1. So divide by 2 this term, or take commonly 2 and bring it to the right hand side, that 2. It will become 0. Now this can be written as d plus 1 by 2 d dash into d minus d dash plus 3 into z equal to 0. Now I rearrange this expression in this form. D minus plus can be written as minus into minus 1 by 2 d dash minus 0. Here there is no constant term, I take it as 0. In the second term, d minus 1 into d dash minus of minus 3 into z equal to 0. Now for this problem, m1 equal to minus 1 by 2, c1 equal to 0, m2 equal to 1, c2 equal to minus 3. Now the complementary function is e power 0x f1 of y minus 1 by 2x plus e power c2, that is minus 3x, f2 of y plus x. This is our complementary function. Right hand side of the given equation have the function x e power y. We have to find the particular integral. Now particular integral is 1 divided by 2d square minus d dash minus d dash square plus 6d plus 3d dash into x e power y. Here the term x e power y is the combination of the polynomial and the exponentiation. The procedure is just bring this e power y to the front side and replace d by d plus a and d dash by d dash plus b. Here we have the term e power y. In e power y, the coefficient of x, that is a equal to 0, the coefficient of y b equal to 1. So now d is replaced by d plus a. Since a is 0, no need to change d. D remains as it is, and d dash can be changed as d dash plus 1. So 2d square minus d, this d dash is replaced by d dash plus 1 minus d dash plus 1 whole square plus 6d plus 3 d dash plus 1 into x, which is equal to e power y. Simplifying the denominator first. This is the denominator, 2d square minus, multiply this d dash minus d minus, this is like a plus b whole square, d dash square minus 1 minus 2d dash, here plus 6d plus 3d dash plus 3 into x. Simplifying this, e power y into 1 divided by 2d square minus d dash, one term containing d dash, so d dash minus d, here 6d is there, plus 5d minus d dash square minus 1 plus 3 plus 2 minus 2d dash plus 3d dash plus d dash. Okay, we have written all the terms into x. E power y. Take a constant 2 outside and bring this denominator to the numerator. I can take 2 outside and write the remaining terms. What will be the remaining terms? I have taken 2, so remaining term 1 will be there surely, plus 2d square, 2 have taken out, so d square here minus dd dash by 2 plus 5d by 2 minus d dash square by 2 plus d dash by 2 whole power minus 1 into x. Here I have taken this constant outside. The remaining terms I have written, that is 1 d square dd dash by 2 plus 5d by 2 minus d dash square by 2 plus d dash square by 2, and I took the denominator to the numerator, so I have written minus 1 whole power minus 1. Can use this bracket because it seems to be 1 plus x whole power minus 1. How to expand this term by using the formula 1 plus x power minus 1 equal to 1 minus x plus x square minus x cube plus etc. Now e power y by 2 into 1 plus the term which are inside the bracket is x. So 1 minus x d square minus dd dash by 2 plus 5d by 2 minus d dash square by 2 plus d dash by 2. 1 minus, this is like x. Next term is plus x square d square minus dd dash by 2 plus 5d by 2 minus d dash square by 2 plus d dash by 2, and the third term is minus x cube minus etc. into the term x, this x. Multiply each and every term with x. We know d means differentiation partially with respect to x. D dash means differentiation partially with respect to y. Now we have the term x, differentiate partially with respect to x, you will get 1. Differentiate x partially with respect to y, you will get 0. D square means twice differentiation with respect to x, d dash square twice differentiation with respect to y. Now you can multiply 1 into that x minus d square 2 times differentiation of x 0, d dash differentiation with respect to y 0, 5 by 2 d differentiation of x is 1. So this term should be included. So minus into plus, minus 5 by 2 d of x, differentiation of x is 1. Or d dash square, differentiation of x with respect to y twice 0, d dash with respect to y 0. This term is like a plus b plus c plus d whole square. If you expand this, you will get all the terms have the second derivative. Surely the second derivative of x, 3 possibilities, d square, d dash square, d dash. This is the 3 second derivative possibilities. D square of x is 0, d dash square of x is 0, d dash of x is 0. So in all the cases it is 0. So surely if you expand and simplify, you will get 0. So I left it. You can stop the process. Simplifying e power y by 2 into x minus 5 by 2. This is our particular integral. Therefore, the general solution is z equal to complementary function plus particular integral. Z equal to e power 0x. E power 0x is 1. No need to write it again. F1 of y minus 1 by 2x plus e power minus 3x. F2 of y plus x. Particular integral plus e power y by 2 into x minus 5 by 2. So this is the general solution for the given partial differential equation. Thank you. Thanks for watching.